Okay, thanks. So I'm Sam. I'm been at Cliqz for just over 3 years, working on the anti-tracking technology. This is part of the privacy team. So as well as this, we're working on lots of different things with these anonymized teammates. So this is anti-phishing, ad blocker, privacy by design, data collection and telemetry, peer-to-peer data sync, and lots of other exciting tech. Okay, so this is about anti-tracking. So why do we actually need anti-tracking? So been some mentions about data being collected about us without us knowing, but can we see what is the concrete reason for anti-tracking? So we can consider online tracking as the collection of a subset of your history by certain third parties. And we can say for any URL that you visit, there is some information that can be gathered from the fact that you visit this page. So one simple example, if you visit a news site, you can learn some things about interests or political interests. If you search for property, for example, on Immobilien Scout, there's lots of extra information transmitted here in the URL. So here it includes where I'm searching in Munich, including the postcode, and how much I'm willing to spend for my flat. Sometimes just the site that you're visiting is telling you something. So if I visit Starship, it's telling you something about my relationship status. Also, when you're shopping online, all of the products that you will look at could be tracked. So for example, I might search for a pregnancy test, and someone can make inferences from this. Finally, also if you're booking a holiday, again, lots of information is included here. So where I'm searching for the hotel, and including what days I'm booking. So each of these individually is leaking some information about me, but if we've linked all these things together, we're starting to build a very detailed profile. This is only 5 URLs. If you imagine every URL you've browsed this week, how much can be obtained from that? And all of these URLs we just looked at, what do they all have in common? Well, they're all going to load a Facebook tracking script. So Facebook is explicitly going to be trying to link this to your data. So if you're logged in on Facebook in this browser, by default, they can add this to your account. So you might not have told Facebook your relationship status, but they would be able to infer it from this history. There's also Google Analytics. This is the most common analytics system on the web. They actually so Google Analytics generally not trying to track you across sites, but we do see cases where they send values which would allow them to correlate these histories they collect. Another one that's also on all of these pages is DoubleClick, which is Google's display ad network. And again, they're trying to build profiles in order to target advertising. And this may be linked with your Google profile. And the fact that all of these sites have these trackers is not actually just a lucky choice by me. Our data from Who Tracks Me shows that Facebook has 30% of web traffic with this pixel, Google Analytics 44, DoubleClick 28. So we can see from this that collecting a browsing history of a user is very sensitive. So each URL is leaking some information, and once we collect these together, this is very easy to de-anonymize. There have been several cases recently, several examples where people have shown these de-anonymization attacks to such an extent that you could buy data from a data broker and then go and knock on someone's door and show them the list of URLs they visited. And the other aspect of this online tracking is that it is totally intransparent. So nobody knows that these companies are collecting this data. And the other aspect is that, so there are these 3 companies with massive prevalence, presence, but there's many more where that came from. So a study we did on the Ghostery data recently showed that 44% of pages have 10 or more companies tracking that you visited this page. And as well as Google and Facebook, there are other companies that are with massive reach across the web in terms of tracking. So given this, we want to try to prevent online tracking. So how are we going to do that? So one of the challenges with anti-tracking is there's a trade-off between protecting the user from this data being collected and preventing the web from breaking. So there's many times that you want to, so you don't want to visit a page and something not to work, and you can't really work out why. Some of you are probably using an ad blocker and then would say, okay, if I have an ad blocker and I load a privacy blocking list, this is also going to protect me as well. So you might say, my ad blocker block solves this. Ad blocker is a binary, so it either blocks something or it doesn't. This means that it's very difficult to catch some of the edge cases of this dilemma. So one example is reCAPTCHA. Your ad blocker probably doesn't block reCAPTCHA because if it does, you cannot log in on lots of sites, you cannot complete forms. But if we look at the way that reCAPTCHA is loaded, it's loaded on the google.com domain. So this means that if this loads with the default browser settings, a third-party cookie will be sent, which is the same as your Google login cookie, which means that Google is able to track this. So cases like this, if I can only block or not block, I cannot protect. So in this case, we need a third mode, which is removing the identifier, which in this case is the third-party cookie. But again, this is not all of the answer. So we might just say, let's block all third-party cookies. But the web has been built with the assumption that third-party cookies are always there. So the web continues to break. So this is, for example, if you try to buy something from Microsoft, they won't let you if you've blocked third-party cookies. Likewise, third-party payment systems like Amazon Pay and PayPal are not going to work. So the first part of the Cliqz Anti-Tracking solution is the heuristic cookie blocking part. And this is just some simple heuristics, so based on user interactions and whether we detect certain common authentication flows. We block cookies unless these things are detected. And this actually blocks 97% of third-party cookies. And these cases that we saw before are solved by this solution. But that's not the whole story. So the other way that trackers can track you is using what's called browser fingerprints. So this is the use of certain browser APIs, which allow you to collect data about the device that you're browsing with and generate something that's unique to that browser. So this is an example of a canvas fingerprint, which uses certain HTML5 APIs to generate a value which is unique to my browser. So the challenge here is that we have to detect which value is actually a fingerprint and which is just normal data used. So here is an example of all the data sent back in a Google Analytics request. So there's lots of things going on here. There's things like API keys, so what my Google Analytics customer ID is, timestamps, random numbers, some browser settings, so there's things like screen resolution included there. But there also might be user identifiers. So how am I going to tell which of these are user identifiers and which are fine? So what can I allow and what do I want to block? So we can kind of work this out if we look at it from two different angles. So the first is what the individual user sees. So for each value he sees, has he seen it? Is it different every time he loads a page? Is it different for each different site you visit, or does it remain the same across sites? And we can also look at what the population sees. So do other users see the same value that this user saw? Or is it unique to them? So if we classify all these different types of values that might be sent, according to this, we actually find this is the one we're interested in. So same value across sites and unique to a user is either a fingerprint or could be used as such. So the way it works in the Cliqz Anti-Tracking system is that what we do is we calculate this. So this is that it's the same value across sites for one user, and it's not something that other users saw. So this first part is pretty easy. You can do a client-side check for that. So I can just see that this value was seen across sites. And the other part we calculate via a k-anonymity check. So what we do is we count across all the user base which values have been seen above k times, and this generates a set of values which have been seen by other users. So there's this asterisk here saying that no raw values are transmitted. Oh, sorry, this is first the quick example of what it looks like in an actual request. So you'd have this Google Analytics request, and then having checked all the values, I'd decide that this one, which is the viewport size, is unique to me, and that one will be removed from the request. So how do we calculate this thing without actually collecting all the data that the user sees and therefore kind of tracking the user? So again, if we have this example, this is a request. It has a load of different parameters in. And we can collect that into a set of messages. So each one just takes each key of value, what domain it was, and the day I saw it. And do this for every single value. I also put this h function, which is a hash function, because I don't need the actual values. I just need to know if they're unique or not. And once I have this, I can split these up and transmit these independently to our backend. So the reason I can do it independently is because I only need to count day domain value. So these won't conflict in my aggregation function. And then by transmitting them independently, we have a framework for transmitting data which anonymizes the IP addresses. So once these have been transmitted, I can no longer link them back together. Okay. Okay, so these values are transmitted, land in S3. Then we can once a day just run a simple Spark job and aggregate like this. So what this means, because the clients are implementing the constraint that they send one message for each of these tuples per day, I can run this statement, and what the count is how many users there were. So if we take this example, I run this, and what it's going to tell me is that this value on Google Analytics is safe because lots of other users saw this one. This comes then in a list which is downloaded by the client, so then you can evaluate in real time which values to block and which ones to allow. Okay, yeah, so this anti-tracking system, been running it for 3 years now, and so yeah, as I said before, we block almost 3 million cookies every day, 7.5 million identifiers. Also now with Ghostery and the ad blocker, there's about 75 million requests that are blocked. So with Ghostery, you can choose if you also want to block. And then this data collection aspect comes to 20 gigabytes of data a day. Who Tracks Me was also mentioned. So now we have over 1,000 trackers, 1,800 websites, 1,700 tracker domains on the website. So what it's doing is telling you for each tracker what sites it's on, what technologies they're using to track you, for each website which trackers they're using. And now we have 13 months of data in there, which is coming to over 1 billion pages loaded by users. And this data is public. You can grab it at the repository if you want to play with the data and see for yourself what's going on. It's all there. So as well as this anti-tracking, we have a lot of other interesting projects we work on to improve it further. So we're looking at hiding IP addresses by proxying them either via other users. Also further pruning cookies, similar to what Apple Intelligent Tracking Protection is trying to do. Having private tabs run in Tor. And also looking at ways of managing consent for the user. So you've probably already got annoyed with all these consent pop-ups in the last month or so. We're looking at getting the browser to handle this for you. And again, we're continuing to expand the public data we put into the Who Tracks Me site. So thank you for listening. Any questions?